Hi guys, welcome to today's teaching lesson. Today we are going to be doing something super similar to what we did on Thursday. However, there's a slight difference. So you're going to be teaching your students how to solve systems of equations by graphing from standard form, so not slope-intercept. Now hopefully you remember there's two kinds of forms. Slope-intercept is y equals mx plus b. There's also another form, which is called standard. Now you've seen this a million times, but just to make sure, standard form is ax plus by equals c. Now, standard form is actually usually more useful for describing real-world situations, which I realize is kind of strange because it is much simpler to graph things in slope-intercept. However, that doesn't necessarily mean that standard form is not useful. Slope-intercept form is a lot easier to graph from, but standard is better at explaining real-world situations. So what I want you to do is have your students run through the do now, just remembering the pattern of how to convert from standard to slope-intercept. We've done this a million times, but hopefully you remember that the key steps you need to follow each time are step 1, add or subtract x and the coefficient of x, and then step 2 is divide by the coefficient of y. Bad y. There we go. This is the same 2 steps you follow every single time. So I'm going to do the first 2 for you, then I'm going to give you a moment to try number 3. So here I would subtract 6x because I need to subtract by the coefficient of x as well as x itself. And I end up with 2y equals 12 minus 6x, or negative 6x plus 12, both are fine. And then divide by 2, and I get y equals 6 minus 3x. And I'm almost done with that. However, that's not good slope-intercept form, so I'm just going to make a couple quick adjustments when I bring it down here and say y equals negative 3x plus 6. That is that one. Now, if we were to do the second one's actually a lot easier. I'd subtract by the coefficient of x and x, which in this case is just x, and I get y equals negative x plus 36. I can start there. I have nothing to divide by, so the slope-intercept form is y equals negative x plus 36. Now, please take a moment, go in and try the third one on your own. Go ahead and pause the video now. All right. So, as we talked about, standard form is actually much more useful for describing real-world situations. So we are going to help out Annabelle with her purse full of nickels and pennies. I realize this is not the most interesting story problem I could have come up with, but it pretty well illustrates why this is useful. So as we're going through, we're going to take a couple quick notes, as we always do, make sure that we understand exactly what it's asking here. Annabelle has a purse full of nickels and pennies. I'm underlining both of those because I'm pretty sure that that's going to be important information in a little bit. How many of each coin does Annabelle have? Well, let's see what other information we're provided. This part says, the coins add up to a total of 32 cents. Well, that means I know this. 32 is equal to something. But I realize I can't really go any further until I've done something, which is creating a let statement. So I'm going to come in here and create my let statement. And I typically like to write my let statements and define my variables based on the information that's provided in the order that is provided. So I say, well, let x represent, or let x be, the number of nickels where, don't mind that, where y is number of pennies. And again, You want to be painfully explicit when you define your variables because it's going to save you a lot of time in the long run. So these are the other things I know. I realize this is probably the most fascinating thing you've heard all day, but turns out nickels are worth 5 cents, pennies are worth 1 cent. Wow, I realize. Now, I come in and say, well, 32 is equal to something. 32 is equal to the number of nickels, x, plus the number of pennies. But I'm not talking about numbers here. I'm talking about cents. So I need to add something in. I need to add that nickels are worth 5 cents each, and pennies are worth 1 cent each. So I've now created a system of equation, or an equation, that says 32 cents is equal to 5 cents times the number of nickels plus 1 cent times the number of pennies. Great, I've created one equation, and I'm going to put it in traditional standard form when I write it over here, just to make sure that it looks better. I'm going to say 5x plus 1y equals 32. Then I come in and I say, all right, well, what exactly other pieces of information are we given? Well, 16 is the total number of coins. And I know instinct says, well, wouldn't I just want to write 5x plus 1y is equal to 16? But that wouldn't be correct, because we're not talking about value now. We're talking about number of coins. And I realize up in my let statement, hopefully you're starting to see why these are valuable, that tells us number. So I just know that the number of nickels, x, plus the number of pennies, y, is equal to 16. So I now have a second equation. X plus y equals 16. Now I encourage you to go in and try graphing this on your own really quickly. Pause the video and take a shot at that. Now hopefully you were able to graph these. I've labeled these the blue and the red line just so it's a little easier to see on this screen. The way I did this personally is I used the cover method. What that means, hopefully you remember, is you're going to cover one and that gives you the intercept for the other one. So if, for example, I were to cover x, the intercept for y is 16. So I put a dot at 16 on the y-axis, and then I do the same thing by covering the y, and I find out that on the x-axis, as you see right there, the intercept is also 16. And I did that for that one. The other method you could have used is converting these into slope-intercept form. So for example, 5x plus 1y is equal to 32. I remember from the do now, I subtract and move. So I get 1y is equal to negative 5x plus 32. Great. That means that my y-intercept is 32. I put that there, and I go down 5 over 1. Or, since I can't really see with this scale down 5 over 1, I went down 10 over 2, because 32 to 22 is a very easy shift to make. So I did that, and then I connect these. Now what that means is this has allowed me to determine that Annabelle has precisely 12 on her y and 4 on her x. So the solution here is 4, 12. But what does that mean in context? Again, we talked about context today. In context, I need to go back and say, well, what did my x values represent? That's nickels. So Annabelle has 4 nickels and 12 pennies.